Welcome to the DIY Honda Garage channel. In vehicles from 2011 to 2017, the Honda Odyssey may experience diagnostic trouble codes DTC P0133 and P0153, indicating a malfunction or slow response from the air-fuel AF sensors. These sensors play a crucial role in the engine's performance by measuring the ratio of air to fuel entering the engine, allowing for optimal combustion and reducing emissions. The P0133 pertains specifically to the rear air-fuel sensor located on bank 1, while the P0153 relates to the front air-fuel sensor on bank 2. If either sensor fails to provide timely or accurate readings, the Engine Control Module, ECM, cannot efficiently manage the air-fuel mixture, affecting engine performance and efficiency. To troubleshoot these codes, it's essential to record any freeze and snapshot data before diving into the troubleshooting steps, as this data can provide insights into how the system was performing at the time the codes were triggered. The diagnostic trouble codes P0133 and P0153 indicate issues with the air-fuel sensor system on the Honda Odyssey. The rear air-fuel sensor, referenced in P0133, is specifically located in the exhaust stream of bank 1, which generally refers to the side of the engine with cylinder 1. This sensor's role is to continuously monitor the exhaust gases for the correct air-fuel mixture, relaying necessary data back to the vehicle's engine control unit, ECU, to ensure optimal engine performance. Meanwhile, the front air-fuel sensor, associated with P0153, is situated in the exhaust stream of bank 2, typically located upstream of the catalytic converter. Its function mirrors that of the rear sensor, but focuses on the opposite bank of cylinders. Both sensors are essential for maintaining the correct fuel mixture, which affects power output, fuel efficiency, and emissions control. Several potential causes may lead to the occurrence of DTC P0133 and P0153. A primary suspect is a faulty air-fuel sensor itself, which could be due to age, contamination, or internal failure. Next, poor electrical connections, including corroded terminals or loose connections, may interrupt the signals sent to the Engine Control Module, ECM, causing a delay in the sensor's response. Additionally, a damaged wiring harness might create open circuits or short circuits, further hindering the functionality of the sensors. The Powertrain Control Module, PCM, while less common, can also be a culprit if it fails to interpret the signals from the AF sensors correctly, or if its programming is corrupt. Each of these possible causes requires careful investigation to pinpoint the source of malfunction. The symptoms associated with DTC P0133 and P0153 can significantly affect both vehicle operation and performance. A common symptom is the illumination of the check engine light on the dashboard, indicating an underlying issue with the vehicle's emissions control system. Drivers may also notice a reduction in fuel efficiency, as the engine may run rich or lean due to incorrect air-fuel mixture readings. Additionally, a rough engine idle can manifest, suggesting that the engine is not operating smoothly, likely due to improper combustion because of erroneous sensor data. Moreover, increased emissions are a possible consequence, as the engine may fail to burn fuel completely, leading to undesirable pollutants being released into the atmosphere. Addressing these symptoms promptly can help prevent further damage to the engine and support optimal performance. The first step in troubleshooting DTC P0133 and P0153 involves turning the ignition switch to the on position, which powers the vehicle's electronic systems without starting the engine. Next, it's essential to clear any existing diagnostic trouble codes using the Honda Diagnostic System, HDS. This ensures that any logged DTCs from prior faults do not interfere with the current diagnostic process. Once cleared, start the engine and hold the engine speed at 3,000 revolutions per minute, RPM, without any load, meaning the vehicle should be in park, P, or neutral. This step is critical because it allows the engine to reach operational temperatures, prompting the radiator fan to engage, which helps in verifying the performance condition of the air-fuel sensors under elevated RPMs. After completing the initial steps, the next phase involves test driving the vehicle under specific conditions to ensure the air-fuel sensors are functioning correctly. The engine coolant temperature should be monitored, aiming for over 158 degrees Fahrenheit, 70 degrees Celsius. This value indicates that the engine is warmed up and operating normally, essential for sensor functionality. While driving, keep the transmission in drive, D, and the engine speed should be consistently maintained between 1,250 and 2,350 RPM. This RPM range allows the vehicle to operate within optimal parameters where the performance of the sensors can be accurately assessed. During the drive, ensure you start from a stop and drive at lower speeds around 25 miles per hour, 40 kilometers per hour, for 5 minutes, then gradually increase to a steady speed of at least 32 miles per hour, 52 kilometers per hour, or more. These varied conditions help stimulate sensor activity and data collection for the HDS. In this third step, you'll utilize the HDS to monitor the onboard diagnostics, OBD, status specifically for DTC P0133 and/or P0153. The goal is to check if the HDS indicates a failed status, indicating an active problem with the air-fuel sensors. If the HDS reports a failed result, proceed to the next troubleshooting step. However, if the system displays a past status or shows intermittent failure, the system may be functioning correctly at that moment. It is essential to check for poor connections or loose terminals at the air-fuel sensors, Sensor 1, and the Powertrain Control Module, PCM, as these areas are common failure points. If the HDS shows executing, continue driving until a result is generated, and if out of condition, return to Step 3 and recheck the previous conditions and sequences. This step begins with turning the ignition switch to the lock position to ensure safety while performing repairs. After that, you will need to replace the affected air-fuel sensor, specifically Sensor 1, which has been determined to be the source of the problem. The process of replacing the sensor is crucial and typically involves removing the old sensor carefully and installing the new one, ensuring that all connections are secure and properly seated. After the sensor is replaced, turn the ignition switch back to the on position, preparing the vehicle systems for the next steps in the diagnostic and corrective process. This replacement must be done with precision to ensure that the new sensor functions correctly and accurately relays data to the PCM. Following the replacement of the air-fuel sensor, the next critical step is to reset the Powertrain Control Module, PCM, using the Honda Diagnostic System, HDS. Resetting the PCM is essential for clearing any stored DTCs and ensuring that the new sensor's data can be registered correctly by the vehicle systems. Once the PCM reset is complete, the PCM idle learn procedure should be conducted, which helps the PCM learn the optimal idle position for engine performance after parts replacement. After completing these steps, you will start the engine again, and it is crucial to hold the engine speed at 3,000 RPM until the radiator fan engages, continuing to monitor how the system reacts at these elevated RPMs. This process validates that the new air-fuel sensor is operational and that the vehicle systems are aligned with the new sensor's readings. The final troubleshooting step involves conducting another test drive under similar conditions to ensure the effective operation of the newly installed air-fuel sensor. Maintain the same engine coolant temperature above 158 degrees Fahrenheit, 70 degrees Celsius. Additionally, take care to keep the transmission in drive, D, and maintain the specified RPM range of 1,250 to 2,350 RPM during the drive. This repeat test is essential not only for confirming proper sensor functionality, but also for checking for any new pending or confirmed DTCs in the HDS. If DTC P0133 and/or P0153 appears again during this testing phase, further investigation is required, which may involve revisiting electrical connections, verifying part installation, or evaluating sensor compatibility. After completing all troubleshooting steps, it's vital to engage in final repair verification to ensure that the issue has truly been resolved. First, confirm that the newly installed air-fuel sensor is functioning correctly and is integrated seamlessly into the vehicle's monitoring systems. This may involve reviewing data streams or graphing parameters with the HDS to ensure the sensor behaves as expected under various engine conditions. Secondly, check to ensure that no new diagnostic trouble codes are present after the repair, as the appearance of new codes could signal other underlying problems that need addressing. Lastly, it's essential to monitor overall vehicle performance for improvements in fuel economy, engine idle stability, and emission levels. Successfully clearing the DTCs and restoring the vehicle's proper functionality indicates that the repair was effective. Preventive maintenance plays a vital role in avoiding future occurrences of DTC P0133 and P0153. First, regular inspections of the air-fuel sensors should be scheduled to catch any issues before they escalate into more serious problems, reflecting their importance in performance and emissions control. Additionally, keeping the wiring harness and connections secure can prevent intermittent failures caused by vibrations or corrosion. Furthermore, timely updates to the engine control unit (ECU) software can enhance overall vehicle performance and address any known issues in the sensor readings or calibration. Following these preventive measures supports the longevity of the vehicle's emission system and maintains optimal performance over time, avoiding unnecessary repairs down the road. In conclusion, understanding the significance of diagnostic trouble codes P0133 and P0153 is essential for Honda Odyssey owners and technicians alike. These codes signal possible faults in the air-fuel sensor system that can lead to poor vehicle performance and increased emissions. Following the structured troubleshooting steps ensures that the underlying issues are accurately identified and addressed, leading to effective repairs. Additionally, proactive maintenance, including regular monitoring of sensors and connections, helps prevent recurrence of these codes and promotes the overall longevity of the vehicle's engine and emission control systems. By remaining vigilant and informed about DTCs, vehicle owners can better safeguard the operation and efficiency of their Honda Odyssey. Please like and subscribe to the channel. See you next time.